Welcome. In our previous video, we explored how to estimate the number of requests in a system using Little's Law. Today, we're diving into another crucial metric for system performance: response time. Understanding response time is essential for anyone who wants to deliver a fast and smooth user experience. Whether you're a developer, a system architect, or just curious about how web applications work, this concept will help you see what really happens when a user sends a request and waits for a response. Let's break down what response time truly means and why it matters. Response time is the total time taken from the moment a request arrives at your system until the response is sent back to the user. Many people mistakenly believe it's just the time the server spends processing the request, but in reality, it's much more than that. Response time includes every moment the request spends in your system, from waiting in line to being processed and finally sent back. This metric is a key indicator of how responsive your application feels to users. Let's break down response time into its two main phases: waiting time and service time. Waiting time is the period a request spends in the queue before the server starts working on it. Service time, on the other hand, is the actual time the server spends processing the request. Both phases are important, and together, they make up the total response time. Understanding these phases helps us pinpoint where delays are happening and what we can do to improve them. Waiting time is the duration a request spends in the queue before the server can start processing it. This happens when the server is busy handling other requests, so new requests have to wait their turn. If your system is frequently busy, waiting time can quickly add up and become the main reason users experience delays. Recognizing the impact of waiting time is the first step toward optimizing your system's responsiveness. Service time is the actual time the server spends working on a request. This includes all the computations, database queries, and any other processing required to generate a response. Service time is often what developers focus on when optimizing performance, but as we'll see, it's only part of the story. Both waiting and service times contribute to the overall response time experienced by users. Now that we understand the two phases, let's put them together. The formula is simple: response time equals waiting time plus service time. This means every millisecond a request spends waiting or being processed adds up to the total time the user waits for a response. By breaking down response time into these components, we can better identify where improvements are needed. Let's make this concrete with an example. Imagine a request arrives at a busy server and waits 80 milliseconds in the queue. Once the server is free, it processes the request in just 20 milliseconds. So, the total response time is 100 milliseconds. Even though the server worked quickly, most of the delay came from waiting in the queue. This example highlights why it's important to look beyond just processing speed when optimizing performance. Notice in our example, the server spent only 20 milliseconds processing the request, but the user waited a total of 100 milliseconds. Most of the delay was due to waiting, not processing. This is a common scenario in real-world systems, where queues can quickly become the main bottleneck, especially during peak usage times. Understanding this helps us focus our optimization efforts where they matter most. So how can we reduce waiting time? The key is to shorten the queue. This can be achieved by adding more servers, increasing the number of worker threads, using load balancing, or even reducing the arrival rate of requests with techniques like rate limiting. Each of these strategies helps ensure that requests spend less time waiting and more time being processed, leading to a faster response for users. Reduce service time. Focus on making each request process faster. This can involve optimizing your algorithms, reducing the number of database queries, adding indexes to speed up searches, using caching to avoid repeated work, minimizing external API calls, and improving disk I/O. Every improvement here means the server can handle requests more quickly, which benefits both the user and the system as a whole. Interestingly, reducing service time doesn't just make processing faster, it also shortens waiting time. When each request is handled more quickly, the server becomes available sooner, the queue gets shorter, and new requests spend less time waiting. This ripple effect means that improvements in one area can have a positive impact across the entire system. Response time directly affects the user experience. Long response times can frustrate users, lead to abandoned sessions, and ultimately hurt your application's reputation. By understanding and optimizing both waiting and service times, you can deliver a smoother, faster experience that keeps users engaged and satisfied. Let's recap what we've learned. Response time is made up of waiting time and service time. Both are important, and both can be optimized. Reducing waiting time often involves scaling your system or managing incoming requests, while reducing service time is about making your code and infrastructure more efficient. Improvements in one area can benefit the other, leading to a better overall experience. If you're looking to improve response time in your own projects, start by measuring both waiting and service times. Identify where the biggest delays are happening. Use monitoring tools to track performance and experiment with different optimization strategies. Remember, even small improvements can add up to a noticeably better experience for your users. In summary, response time is a vital metric for any system that handles user requests. By understanding its components and knowing how to optimize both waiting and service times, you can create faster, more reliable applications. Keep these principles in mind as you build and maintain your systems, and you'll be well on your way to delivering outstanding user experiences.